Video is going to review the quadratic formula with both rational and irrational roots. So I'm going to start with number 3. And number 3, I need to arrange this in standard form before I can get started. Identifying A, B, and C. A is 1, B is -8, C is -20. Going into the formula, x equals negative b, notice I have that double negative sign, negative b plus or minus the square root of b squared, making sure that I square that negative sign as well, minus 4 times a times c, and all of that over 2 times a. So I've got my formula set up correctly. In the next step, I'm going to clean this up. 8 becomes positive. Plus or minus, that's going to be 64 plus 80, which is going to result in 144. 64 plus 80, 64, and this results in 80. Adding those two together, I get 144, and then my denominator is going to be 2. 144 is a perfect square, so the next layer is going to be 8 plus or minus 12 over 2. So here I'm going to get this rational root outcome, a rational number. I have a rational root outcome when I have the perfect square underneath the radical. That results in the rational root. And we'll do other videos discussing this to make sure that you thoroughly understand it. Now I'm going to deal with the plus negative portion of the formula. So my first root is 8 plus 12 over 2. 20 over 2 results in 10, so my first x value is 10. And then my second root is going to be 8 minus 12 over 2. That's going to be -4 over 2, and that's going to result in -2. So these are my two roots. Notice that they are rational numbers. I'm going to erase some of this just to draw an analogy, and as I said, we're going to explore the topics I'm discussing now further as we study this the quadratic formula and quadratics in general. Notice that if I chose to factor this, I would be able to find factors of -20 that would sum to -8. When the roots are rational, that means that I could use the big X. That means that this quadratic is also factorable. And the key way to recognize that, if you don't recognize it right away, is that perfect square underneath the radical. So as you're using the quadratic formula, when you get a perfect square underneath the radical, that is a cue to you that you could have also solved this by factoring, meaning that the big S method would also work on this quadratic. So what I need to do now is analyze what happens when you don't have a perfect square underneath the radical. So I'm going to go back to number 1 for that. Number 1 is already in standard form, and let's identify A, B, and C. A is 1, B is 10, and C is -2. If I were to try to do this by factoring, the product of A times C is -2, B is 10. That means I will be looking for factors of -2 that sum to 10. No such numbers exist, so that means that this is not factorable. That means the only way to solve this is by using the quadratic formula. So let's go ahead and set this up. So x is going to equal -b plus or minus the square root of b squared. B squared is 100 minus 4 times a times c, all over 2 times a. So what happens now? I have -10 plus or minus 108 over 2. So the next skill to learn is how to simplify this in radical form when you have a non-perfect square underneath the radical. And the next problem set, we're going to explore that just for a minute, just to make sure that that skill is good with you all. So here this is actually going to be 36 times 3. 108 is 36 times 3, and then my denominator is 2. The square root of 36 is 6. And I'm going to stop here for a minute, and I'm going to go to another problem set just to teach you how to correctly simplify this in reduced radical form. So keep your notes there, and we're going to go to another page to practice that skill for just a minute. But before I erase all of this, just to recap, when I get a non-perfect square underneath the radical, that's my cue that this is not factorable, and we can see right here by trying to set the big X up. This is not factorable, and the only way to solve this, the only way to arrive at the roots is to go through the quadratic formula. So the next skill for me to make sure, the next skill that I need to make sure you all understand is how to simplify this in reduced radical form when you have the non-perfect square. Let's move to the next page and do this. So here I have 6 plus or minus radical 32. Radical 32 is 16 times 2. 16 is the perfect square. When you have a GCF and the 3 spots that I'm going to highlight in red, you can remove their GCF. The 2 underneath the radical is off limits because it's not really a 2, it's the square root of 2. So in order to simplify this properly in reduced radical form, I need a GCF in the 3 spots sitting outside of the radical. All three spots must have a common factor. In this particular expression, they all share a 2, so my simplified answer would be this. I would remove their common 2, and that would be the most simplified form of the expression that I originally started with. Let's do number 5. So number 5, 128 underneath the radical. So I've got 4 plus or minus. 128 is 64 times 2. 64 being the perfect square. So I've got 4 plus or minus 8, radical 2 over 6. Notice that I've got a GCF in the numbers that I'm making red. They all share a 2. The 2 underneath the radical is off limits because it's not really a 2, it's the square root of 2. I remove the common GCF among 4, 8, and 6, and my simplified answer is 2 plus or minus 4, radical 2 over 3. And I would like to analyze this for just a minute. Notice that 2 and 4 share a GCF, but 3 does not share the same GCF. Therefore, this is in its most simplified form. You cannot take this down anymore because you need, in order to simplify it as in the reduced radical form, I need the GCF in the 3 key spots that I'm highlighting there. And let's do one more problem on this video. Looking at number 6. Number 6, I have a negative underneath the radical. I have negative 300 under the radical. This is a situation where you would have non-real roots. Or in Algebra 1, you could simply say no solution. In the world of real numbers, you cannot take the square root of a negative number. This is beyond the scope of our course. This is a topic that you'll study when you study imaginary numbers in a higher level course. But for us, in the world of Algebra 1, if you have a negative number underneath the radical and you're looking for a square root, this is a situation where you would just simply say no solution, non-real roots. Now let's go back to the problem that we were working on. Number 1 on the other page. We stopped here. Let me recreate what I had, and I believe that we were right here. Now you have the skill set or the understanding to simplify this properly. Notice that I would have a GCF of 2 in the 3 spots that are outside the radical. I would remove that GCF, and my simplified answer would look like this. actually I would have a denominator of 1, and the way that I would present the answer, I wouldn't use the denominator of 1, although it's not wrong to do so, but I would present my answer like this. My x values, this would be my solution set.